Hello students, my name is Shashank Shekhar and today is the second day of the chapter, that is Haloalkane and Haloarene. So we have started this chapter yesterday and we have seen the classifications. Okay, so if you look at the syllabus here, so we have basically seen an introductory part of this. So today we will begin with the syllabus. So I will be teaching today the nomenclature first of all and the nature of CX bond. So we know that halogen compound will contain a CX bond because we have replaced one hydrogen with a halogen. Now there exists a bond between carbon and halogen. So we'll look upon this, what kind of bond it is, what type of reactivity it shows, and what is the strength of this bond and bond length and etc. Okay. So one more thing, I will be today discussing the nomenclature of haloarene along with this haloalkane. Okay, so we'll not get a separate class for it. We will discuss it along with this haloalkane. Okay, so let us start our today's class. So if you look at the topic, so we have this nomenclature of halogen compound. So we'll go through various steps for it. First we'll find the longest chain, then we will number the carbon atoms, then we will name the halogenated compound. Then we will see different cases because this is the simplest case that we have handled through these steps. But what happens if more than one halogen atoms are present? Then after that we will see the nomenclature of haloarene, and at last we will see this the nature of CX bond. Now students, I would suggest you that you focus on this part more. Nomenclature you must have studied in class 11 also, and it would not be that much difficult for you. And for those who have not studied, still we will go through each of these steps very minutely. You don't have to worry about it, but I want to make assured that you get the proper idea of the CX bond nature, because it's more important one. Because in the exams or any of the exams, you say JEE or you say NEET, you have to mainly discuss about the reactions and all. Of course, you have to be aware about the nomenclature, then only you will be able to identify the compound. But the reactions you have to carry out would require the proper idea of this, say, CX bond. Then only you will be able to identify that whether this bond will be cleaved or whether this bond will be formed or not. Okay, so this is very important. Do not just say that okay, this is just a side part. This is the main part. This will form the basis for all of the reactions that you will see later on. So let us start our today's class. First we will see what is the nomenclature. So and then you must have studied this IUPAC system. So first of all, what is this IUPAC system? So it is basically a system which is developed in a standard form so that the naming of the compound can be done and there should be no confusion. Like, suppose you are sitting in India and someone is sitting in USA. Both have done some research, or suppose you have done some research, then you will have to publish a paper. Then in that case, suppose you have done your research in organic chemistry and that involves various compounds. Now you have written your thesis. So you will have to mention the name of the compounds. If someone from a different country like US or Germany or any other place have to take reference from your journal or from your thesis. So if the name that is to be followed for the compound is not kept same or is not standardized, then it would be difficult for him or her to read that paper or the thesis which we have written. So to avoid this confusion and to make science more helpful for all of the people around the world, we have developed a system so-called IUPAC system. Now you have to name all the compound on the basis of this system so that there is no confusion. Of course, there is common name for each of this, but that's a different case. Okay, so today we will be focusing on this IUPAC name. So if this full form is International Union Pure and Applied Chemistry. Okay, first let us start with a simple compound. The simplest compound I have taken is of methane, ethane, propane, butane. How many carbons? 4 carbons. So you know this, 4 carbons means butane, 6 carbon means hexane. I have not put that thing because that is quite common. For those who don't know, so I will just give a quick one for you. For the 1 carbon we have meth as the suffix, then we have eth. For 2 carbon, 3 prop for 3 carbon, then we have but, 5 we have pent, 6 we have hex, 7 we have sept, 8 we have oct, 9 we have nano, 10 we have decade, and so on. So you must remember at least this. Okay, now if you see here, we have 4 carbons. So first we will have to find the longest chain in this. So it is easier to find because only one chain is present, but in the next slide you will see a variation of chains. Then it will be difficult for you to find that. Okay, so we will do an exercise on it. It is a kind of very minute thing, and children often make mistake in this. Okay, so keep a keen eye on this, finding the longest chain. So what we will do, we will first find the longest chain. The longest chain of the carbon atom, the above example is shown in the box. So the longest chain is this one, and this is the only chain, so it will be the longest and the shortest, whatever you say. There is no reference for it, but for now just assume it at the longest chain. Now let us have some examples. So this is the example that I have put. Now we will try to find the longest chain in each of this. So for that, what we will do, we will try to number it. Suppose we have started numbering from here. So this will be 1, 2, 3. So we go on either this side or this side. So since it's symmetrical, this will have the same number of carbon, 1, 2, 3, 1, 2, 3. Okay, 1, 2, 3, 4, 5, 6. So 6 carbons. So one chain. This is the first chain we have considered. How many carbons are involved? 6 carbons. Let us take a different case and try to number it again. Suppose I am doing it with the green. Suppose 1, 2, 3, 4, 5, 6, 7. How many carbons? 7 carbons. So which is the longest chain? Then we would say that, okay, this one is the longest chain. So we have found our longest chain in this. Similarly, let us do for this. So first let us try to do with this one. Okay, so this is 1 carbon, 2 carbon, 3 carbon, 1. I am numbering it again. 1, 2, 3, 4, 5. So this chain is of 5 length. Let us try it another way. So it will be, let us do it from here. 1, 2, 3, 4. So it is smaller than this, so we do not have to consider this one. Let us take another one. 1, 2, 3, 4, 5, 6 carbons. So this one is the longer one. So which is the longer one in this? So you can try all of by yourself. So I am doing it one by one slowly. You can follow, or if you are fast enough, then you can go forward and solve all of this. Then verify your answer that whether you have done correct or not. I would suggest that this is a very good practice, and it will make your doing the way of nomenclature more clear. So you will make less mistakes. Okay, so this practice is very good for your nomenclature system. Now let us see this compound. So first we will try to number it from here. 1, 2, 3, 4, 5, and 6. Okay, so first one goes like this. We could try a second one. 1, 2, 3, 4, 5, 6. Okay, now what did you find? That 2 of these chains, that is this one and this one, they have the same length. Now keep this example right now for take a halt. Keep this one for your next rule. So this will be clarified for with the next rule, that which chain you have to consider. So you will see this example again. So let us keep it at halt. This one. Moving to the next one, what we have. So we can start from here. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons are there in this chain. We can try another one. 1, 2, 3, 4, 5, 6. Okay, so this is smaller than the previous one. We will not consider this. Let us take a different one. So 1, 2, 3, 4, 5, 6, 7, 8. Again, this is greater one because this one was smaller. This was 1, 2, 3, 4, 5, 6, 7. So this was of 7 length, and now this one is of 8th length. So this is longer one. Which is longer one? This one. Okay. Similarly, we can do it for this one. So let us start our numbering from here. 1, 2, 3, 4, 5, 6, 7. Sorry, 7 and 8. First case. Let it as this one. Let us take another case like this. 1, 2, 3, 4, 5, 6, 7. It was of 1, 2, 3, 4, 5, 6, 7, 8. But this is of 7 only, so it is smaller. Let us take a different case. 1, 2, 3. Let me erase for you. 4, 5, 6. It is still smaller. So all these are smaller, only this one is larger one. Now you would say, sir, we have another possibility also. Which one? You will say that, okay, sir, we can do this one also. That this is 1. Sorry, let me use a different one. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. So this one is also of 8 chain. This one is also of 8 chain. But if you look here, then you can see that this is kind of symmetrical. So if you start numbering from here or either here, since no substituent is present, extra substituent is present, so we can consider both. Okay, so we can consider any of these two. So these both are correct. So do not get confused. You can take either of this. If both have the same variant. Okay, so this is same and this is also same. So we can take either of them. Next example. Okay, this one. Let us start our numbering from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we found 11 chain here. Look like this. If you try it from here, I think it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is also 11. So let us try a different one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is the longest one. This is the longest one. Okay, this is clear. This is clear. Okay, right. Now you have your longest chain. This is the first step. The first step is done. We will see this thing, see the same structure in the next slide also, where you have to further number it. So keep this in your mind, or we will do it again for the next class. For the next slide, we will do it again. So this will make your practice better and better. Now second is numbering. So suppose we have found a chain. Suppose this is our chain, and this is the same one. Now we can number it from two sides. We can start from left, 1, 2, 3, 4, or we can start from here, 1, 2, 3, 4. So what did you find here? You found that, okay, both are the same length because we are counting the same chain from the opposite side. But in this case, this chlorine is getting a smaller number, that is 2. But here the chlorine is getting a greater number, that is 3. So what we will do, we will take that carbon or that counting, that counting which has the substituent at the lower position. So this one is at the lower position. Here it is at 2, but here it has 3. So we will take this one, this numbering. Okay, we will take this numbering. So numbering is done. So what does this second rule says? So first you have to find the longest chain. Once you are well through this longest chain, you will try to number. And number in which way? Such that the substituent should come at the lower numbering. This is clear? So the same thing written here. In the above example, the numbering shown in first is correct. Why it is correct? Because the second one, the carbon bearing the atom is at lower number in 1 than 2. Okay, so this is clear. Now what we will do if two halogens are at the same position? Suppose we have a bromine here. Then if you start numbering from here, then also we will find substituent at 2. And if we started numbering from here, then also we will find substituent at 2. So if two halogens collide, then we will follow the alphabetic order. The one whose name has alphabet priority will be given the lowest numbering. So if I have written bromine here, then the numbering will start from here, 1 2 3 4. Did you get my point? So I am saying that, suppose, let me do it here for you. Suppose bromine is written here. Now bromine starts with B and chlorine starts with C. So since B comes first, so we will give bromine the priority. So suppose at 2 here, at 2 position, bromine is attached. Then we will do the numbering from this to this. Okay. So if you follow this alphabetic order, then first bromine will come, then chlorine. Oh, sorry for this order. It's longly written. We have firstly bromine, then chlorine, then fluorine, and then iodine. So this is the order that we will follow. So what did I say in this whole slide? First of all, you will find the longest chain. Then we will try to number it. We will try to number it from both sides, and you can have 2 possibilities only. So at the point you have found the longest chain, you can do it from 2 sides, either left or either right. Okay. Now we will do the numbering from that side where substituent comes first. So here we have that example. Now the second thing I have mentioned is that if two halogens are coming at the same priority, like here if we count from here, we will get chlorine at 2. If we count from here, we will get bromine at 2. Therefore we will now follow the alphabetic order. We will take that numbering which has alphabetic priority. So this is the example. So if we now give the priority according to alphabets, then bromine will come first, then chlorine, then fluorine, then iodine. Okay, so this is clear. Now let us come back to our previous examples. Now what I have done, I have introduced the halogen atoms here along with the chain. So if you remember, we found earlier that the longest chain was this one. We have found this. You can do it again for you. Now we'll start numbering. So we can do numbering from 2 sides. Suppose we have started from here. 2 3 4 5 6. So if you see here, then we can see that if suppose I am doing it with blue, we have found that if we do from numbering from left, we are doing the numbering from right here. Sorry, if we are starting the numbering from right, then we are getting chlorine at 2 number and fluorine at 6 number. Okay. Now let us do it from left. Let us do it from left. So what will happen in this case? We'll have 1 2 3 4 5 6 7. So here at number 2 we have fluorine, and number 6 we have chlorine. Now we have seen earlier that we have to prioritize the alphabet. So this one goes correct because we got chlorine at a smaller number. Therefore, first of all, this will be the longest chain, and the numbering will start from the right side. 1, 2, 3, 4, 5, 6, 7. So we are done with this numbering. Next, we have found that okay, this is the longest chain possible in the earlier slides. Now we can do the numbering from right. We can do the numbering for left. So it is very clearly visible that if we do it from here, then this will get the smaller number 2. Clear? Now one more thing, that if any other substituent is also present and that is also that is suppose at the smaller place, so that we will do counting according to that. So it is general rule what, that we will do counting from that side where substituents can come first. Okay, so it does not matter where chlorine or it is not only for halogen, it is for any substituent. So if suppose any substituent is coming at number 1 and the chlorine is at number 2 from the other side, then we will take the number 1 side where the substituent occurs first. And if both and 2 substituents are coming at the same position, then you have to go back to your priority series and look at it. I will not go to that now. We will just focus on our halogens. Now coming to this, we have found that we can have 2 cases. So this one has 2 cases, I remember. Okay, so we start the numbering. So the first case was 1, 2, 3, 4, 5, 6. So it is also 6 and it is also 1, 2, 3, 4, 5, 6. Now these 2 chains are possible. 2 chains are possible. So I have mentioned it earlier also. So first chain is this one and the second chain is this one, which is going from here to here. Now which we will number, this one or this one? Now I have told you earlier that we will number from that chain only in which substituents come first. Now we can see very clearly that both of this has a methyl on number 2, but this chain, so you can see that this methyl is at number 2 for both of these chain. Now but you can see here that fluorine, it has number 1. Fluorine is at number 1 in this chain. So we will take this green one. Okay, and where we would start numbering it from the right. It should be clear. Okay, so this would be looking like this. So this would be our numbering. Next, another example. So we have if you remember, this one was the longest chain. So which side we will start numbering? Of course from this side, because this one is having the longest chain and substituent at the smallest priority, that is number 2. Next, this one. So now if you look here, we have 2 possibilities here also. So this one is the first possibility and this one is the second possibility. Now which chain you will take? Orange one or green one? You will say, sir, we will take orange one. Why? Why orange one we will take? Okay, we will take orange one because this halogen is coming at a smaller place. This halogen is coming at a smaller place, that is number 3. So we will take that orange one. So the numbering would go like this. So this is our chain that we are taking. Now for your knowledge, I would tell you that comparing alkyl and halogen has a greater priority. Okay, so this should be clear because I have used only alkyl and halogen here. So this should be known to you. For this chain, we have remembered that this one was the longest chain. And where we will start numbering from? We will start it from this side. So we are done with this numbering for all of this carbon. So you should do it too by yourself. You should try it once more. Just take the screenshot, take your pen and paper and try to solve it. So it will be very beneficial for you to do this practice, to count the numbers and then to assign the parent chain. Now the chain we have got, which has this longest chain, is termed as parent chain, and we have got the numbering. Now we are left with naming. So we will give the name. So in case of any other substituent is not present, we name it as a suffix. So halogen is named as a suffix. So suppose our foremost example and the primitive one we have taken, I will not say the primitive one, but the primary one we have taken for our better understanding is this one, this chain. So we have done accordingly. We have assigned the longest chain. We are done with the numbering. Now we will name it. So chlorine is a number 2. Therefore, we will name it as 2 hyphen. Keep these minute things in your mind. We are having a hyphen here. So this is very important to put a hyphen. Then 2 hyphen chlorobutane. 4 carbons are there, so butane. No double bond, single bond, no double bond, triple bond, therefore ane. So 2 position we have chlorine and 4 carbons, therefore we have 2 chlorobutane. Is this clear to you? So in this way you have to name your compound, name your halogenated compound. Now what happens if we have more than one halogen on the same carbon? Or on the same carbon or different carbon, any of that. So in that case we will use this prefixes. I have told earlier that halogen compounds means halogen have suffix, not suffix. It will have prefix. Sorry for the confusion. It will have prefix because chloro is a prefix, not a suffix. Prefix is something that comes at first. So you can see here that it is coming at first. So this is a prefix. Now if you have more than one of the same halogen, then we use this prefix di, tri, tetra, penta, hexa, etc. So what it is written, when 2 or more halogen are present in a compound, the longest chain is selected and it must contain the maximum number of halogen atom. So this is also very important. Suppose 2 chains are there, then we should select that one which has the maximum number of halogen atoms. Is this clear? Okay. Now the multiplicative prefix means which is multiplying the number of your halogen, are added before the name of the halogen to indicate the number. So this is indicating the number. Of course, this di is relating with 2 halogens, tri with 3, tetra with 4, and so on. So let us see some examples here. So look at this nomenclature very minutely I would say. So what we have, the number of carbons here, that is 2. So we have ethane. Number of chlorine, 2. So di. Since it is chlorine, we will have chloro. Now we'll start numbering from this side because chlorine comes first at this one. Now we have 2 chlorine on the same carbon. So we will write it the 1 2 times. 1 1 along with a comma. 1 1 then hyphen dichloroethane. So this is our complete name. What are the technicalities you have to see? First, you have to select the longest chain. So this one is the longest chain, of course. Now you have to do the numbering. So we'll do it from here or here. We'll do it from here. Why? Because chlorine comes first. Now we'll number it. So one more thing, if more than 1 are present, we have to use the word di, and since 2 are present, we will write 1 for each of these. 1 1 dichloroethane. Clear to you? Okay, because both of the chlorine are present at first position, so we'll write both 1 for both of this. Is this clear? Okay. Now next example. Again, find the longest chain. This is the one. do the numbering, we can do it from here or here. We will do it from here because it comes at first. Okay, clear? Now we will start the naming. So one bromine is present at 1 first position and the second is present at 2. Therefore we will write it as 1, 2. Okay, 1, 2, and since 2 bromine are present, we will write it as dibromo. And how many carbon? 3 carbons, therefore propane. Now remember these things. Okay, so this comma and this hyphen, these are also very important in board exams. Marks are deducted for this small mistakes. Okay, so remember these things, this comma and hyphen. Okay, now this one, now longest chain. So we have 2 possibilities. First is this one, second is this one. So let us first number it. So 1, 2, 3, 4, 5. This chain is of 5 length, 5 carbon length. This is of 1, 2, 3, 4, 5, 6. This is of 6. So we will take this one, of course. Now numbering can be done from 2 sides. 1, 2, 3 here. And the other numbering can go as 5 and 6. Now which side we will start numbering? If you see here, we have 2, we have chlorine on both sides. Okay, at 2 position. Here also at 2 we have chlorine, and here also at 2 we have chlorine. Now we will move to the next carbon. So for this we will move to the 3rd carbon, and for this we will move to its 3rd carbon. Now its 3rd carbon has a substituent present. There is a substituent present, but for this 3rd carbon no substituent is present, so it is coming here at 3rd position. So we'll do the numbering from left side. So this is clear for you. So first we collected the longest chain, then we have done the numbering. We have seen that chlorine is occurring at the same number from both sides, so we move to the next corresponding substituent, or you can say carbon, and then we looked for substituent. Then we found that upon numbering from left side we are getting this substituent at 3 number, and but from right side we are getting at 4 number. Therefore we will do it from the left side. So let us start our name. So first we will put this dichloro thing. Okay, so at 2 and 5 we have chlorine, therefore 2, 5 hyphen dichloro. Now remember this thing. Okay, so we have to put 2 hyphen if we have another suffix. Okay, if we have another suffix, we have to put again 2 hyphen. So 2 hyphens are this and this. Then at what position it is present? 1, 2, 3, 4, 5 and 6. So at 3 position we have this ethane. Okay, so we will write as 3 ethyl, and how many carbons? 6. So hexane. So 2, 5 hyphen dichloro hyphen 3 hyphen ethyl hexane. 2, 5 dichloro 3 ethyl hexane. So it's a very good question to ask for. You can make mistake. You can in what places you can make mistake. First of all, you will have a confusion that which carbon has the longest length. Second, the most unavoidable confusion I could say, that which side will start numbering from. Okay, and the third mistake you would make is putting 2 hyphens. Okay, so this should be clear. Okay, so we are done with this haloalkane nomenclature. Now we will move to nomenclature of haloarene. So haloarene, which is directly, what are the haloarene? First of all, in which the halogen atoms are directly linked to the aromatic ring. So those compounds are termed as haloarene. So if you talk about the general formula, it is ARX, where AR represents our aromatic system and X represents our halogen. In naming a haloarene, the prefix chloro, bromo, ido, etc. is added to the name. Again, we will add the prefix as chloro, bromo, ido. And the relative position of the halogen atoms are used by appropriate numbers. The prefix ortho, meta, para are also commonly used. So this is the common system of naming, ortho, meta and para. But this is very important. You will not see this 1, 2, 1, 3, 1, 4 in case of benzene. You will always face this ortho, meta and para. So you should be very clear about it. So let us do some examples to make our concept more clear. So these are some examples that we have. So first one is easier one. We have a chlorine, therefore chloro, and a benzene, chlorobenzene. Clear? Next, what we have? We have one chlorine and one methane. So we'll start the numbering from the methane side. We'll give priority, alkyl the priority. Okay. So the first priority is given to this. So 1, 2, 3, 4, 5, 6. So at first position, we have this. This it is a methyl group. Now one thing, it is not mentioned here. If you see, it is not mentioned that 2-chloro 1-methyl toluene. Sorry, 2-chloro 1-methyl toluene. It is benzene. It is not mentioned like this. Instead, it is written as 2-chloro toluene. So why is it written so? Because this thing is called as toluene. So first we have named all of this compound as toluene, and then we have put the prefix as 2-chloro. So 2-chloro toluene. Again we have 3-bromo toluene. Now we can name it with the help of ortho and para also. So if I write it for you, so let me make a bigger picture for you for ortho and para. Suppose your substituent is here and you have to assign ortho and para with respect to this. Remember, this ortho and para is a relative configuration. You cannot name, okay, so this is ortho or this is para. It is not like that. With relation to it, we will name it ortho and para. Suppose with relation to it, it is as this is a 2 number. So we will name it as ortho. 2 position is ortho. Similarly, this is a 6 one, so it is also an ortho. At 5 we have ortho, and at 3 we have ortho. Sorry, meta. Here also at 3 we have meta, and at 6 we have para. So keep this in mind. So if I write you here, 2 and 6 are ortho, 3 and 5 are meta, 6 is para. Clear to all of you? Okay, we are done with this. Now at 2 position chlorine is present, therefore orthochlorobenzene. So ortho is abbreviated as O, orthochlorobenzene. Similarly, here bromine is present at 3rd position, so you can see that at 3rd position it is meta. So meta has a abbreviation as M, ortho as O, and para as P. So M bromo, again toluene, here using the word toluene for whole of this. Now this one, at we are not mentioning first position. First position is obvious, so we are naming it as 4-bromo chlorobenzene. So it is as 4 position, so 4-bromo chlorobenzene. So I think this is written wrong. We have to use the alphabet one. So this one will be 1 and this one will be your 1, 2, 3, 4. So its name would be 4-chlorobromobenzene. Sorry for the mistake, because this in case of halogen we give priority according to the alphabet. Now here again we have toluene. Now we'll start numbering it. So we will start numbering from here, 1, 2, 3, 4, 5, 6. So we'll name it as at 2 and 4 it is present. This chlorine is present. Therefore we'll write it as 2, 4 dichloro for 2 chlorines and toluene for whole of this thing. Again we have 1, 2 dichlorobenzene, 1, 2 dichlorobenzene, or we can say that suppose we have started numbering from here, then it is at number 1. So we will write this one as ortho dichloro, because both of this are ortho to each other. Okay, so if you consider this one and start numbering, we'll start from the side which has the least numbering to the substituent. So from this also we are getting it as 2, and from this also we are getting it as 2. So this is a relative kind of ortho dichlorobenzene. Similarly, 1, 4 dichlorobenzene, or we can write it as para dichlorobenzene. So this is clear to all of you? Okay, so this is the naming of haloarene. Now we'll move today's last topic, that is nature of CX bond. Now if you see CX bond, then you will find that, okay, so I've not put up a picture here, sorry for that. So I'm drawing it here. Should I draw it here? Okay, so I'm drawing it here. This X is always more electronegative than the halogens are more electronegative than carbon. So it will develop a partial negative charge. And since carbon is electropositive than this halogen, it will have a delta positive charge. Okay. Now since we have a distribution of charge, one has more charge, one has less charge, so we kind of are creating a dipole. So this is the dipole that we have. So the dipole direction will be positive to negative. Okay, for the physics one. So from physics point of view, the direction of dipole will be opposite. So do not get confused. Okay. So for chemistry, we go it from positive to negative, but for physics, we go it from negative to positive. Now we know that carbon bears a partial positive charge, whereas the halogen bears a partial negative charge. Now as we go down the group, we know that the size of halogen increases. Halogen atom size is increasing because the number of shell is increasing one by one, and the number of shell increasing is resulting in the size of the halogen increasing. Therefore fluorine has the smallest size, then we have the chlorine, then we have the iodine with the largest size. So if I talk about the fluorine, so fluorine atom is the smallest and iodine is the largest. Now due to this, the carbon halogen bond also increases from CF to CI. Okay, so did you get my point? So since this size is increasing, the distance between carbon and fluorine is also increasing as we go down the group. Therefore bond length is also increasing. 139, 178, 193, 214. Now if the bond length is increasing, therefore bond enthalpy will decrease, because it will be easier for us to break the bond. So it has this CF will have a bond enthalpy of 452, and bond enthalpy is for 1 mole of bonds. So this is for 1 mole of bonds, again 1 mole of bonds, and again. So you can see that as we go down the group, bond length is increasing and your bond energy or bond enthalpy is decreasing. What about a dipole moment? Again, the one with the greater, you can say greater electronegativity would have the largest dipole moment, because there will be greater distribution of charge. But there is a small, you can say small exception. Why is it so? So if you look here, this was 1.847 dipole moment and it is 1.860. So this one is greater than this. Down the group, then it is good with this electronegative concept. But this and this are contradicting our very basic concept. Why is it so? So if you look at the periodic table, you will find that fluorine and carbon add at the same period, whereas this carbon and chlorine are in different period. Now because of the same period, what happens is that the fluorine has a tendency to donate its lone pair into the anti-bonding of this carbon. Did you get my point? So now we have said that more number of electrons is on fluorine because of the electronegativity, but at the same time the fluorine has a tendency to donate its electrons to its carbon because both have the second energy level 2. Okay, now due to this reason, kind of this is decreasing the charge on fluorine. The negative charge is decreased on fluorine, and since the charge has decreased, this has quite lead to the neutrality. So it is pointing towards neutrality. Not I'm saying that it has become neutral, but due to this transfer of electron from fluorine to chlorine because of the same size or the same energy level, there is a kind of decrease in the charge distribution. Now the charge it should have due to electronegativity has been decreased due to the donation of electron. Therefore, we can see a decrease in the dipole moment. So this is the exception, and you should be noticing this. Now you will say, sir, why it is not happening in case of carbon and chlorine? So chlorine is of greater atomic number, or you can say is in different period. So their energy level of the HOMO and LOMO, so do not get hyped. HOMO means the highest unoccupied molecular orbital, and LOMO means the lowest occupied molecular orbital. So there you can say basically the orbital which has to donate electron and the orbital which has to receive the electron should be at comparative energy. Then only this donation will take place. So since the chlorine is at a higher period, so it will have your say electrons at a higher energy, and it will be difficult for it to donate you to your carbon. Due to this reason, we see a less contribution of this donation and more contribution of this electronegativity. And as we go down the group, this contribution reduces, you can say, in the vast form, and hence we got a dipole moment according to this electronegative difference. But you should remember this. You should remember this exception. So this is the most important thing to notice here. So this is clear to all of you. Now we have discussed the nomenclature and we are done with this, say our nature of CX bond. Now we'll move to the reactions in which both of this will be used, because it will be written that this react with this. So you have to find you have to be good with this nomenclature, and this react with this to give this product. So if you are to validate the product, you must know the reaction path, and for that you must know the nature of your CX bond. So is this clear to all of you? So this was for today's class. From the next class we will see the preparation of this haloalkane and haloarene. Okay, thank you. So specifically we will talk about haloalkane. Okay, thank you for today's time. With this I end my lecture.